A recent poll indicated that about 70% of US households had access to a high-speed internet connection. Part A asks, suppose 100 households were randomly selected from the United States. How many of the households would you expect to have access to a high-speed internet connection? I think the value would be, you would take the total number of households and multiply it by this percentage, which, that's a pretty easy computation. It'd be 78. So I'd expect 78 out of 100 of the households to have access to a high-speed internet connection. And the reason is, if you took these two numbers, 78 and divided it by 100, no surprise, you get 0.78, which takes you back to the 78%. So I think that's really it for this part of the question, just multiplying the percentage to the total number of households that you sample. And then for part B, now moves on to a probability type question. If 20 households are selected randomly, what is the probability that exactly 12 have high-speed access? And this is a binomial probability experiment. So to answer this question, I'm going to use StatCrunch. So from question help, I'll click on StatCrunch. And I'm going to access the binomial calculator. So I'll go Stat. I'll select binomial. It's not showing. Let me try that again. Stat, here it is, binomial. Okay, I want to enter in the corresponding information from this question into here. So for starters, if we are selecting 20 households at random, 20 is going to be the value for n. That's the number of trials in your sample. The probability of success corresponds to this 78%, which I'll put as 0.78. And if I want to know the probability that exactly 12 households have access to high-speed internet, the exactly is telling me, okay, use equals, and the number is going to be 12. And I'll click compute. If I round to 3 decimal places, the probability is 0.035. So about 3.5%. Part C asks, if 20 households, again, are selected randomly, what is the probability that 12 or fewer will have high-speed access? There's very little that we have to change to get the answer from part B to part C. All the values are the same, but if we want 12 and every possibility less than it, I'll switch this to less than or equal to. I think it already did the computation for me. The probability went up a little bit, not a whole lot, but rounded to 3 places, it's now 0.054. So that was 0.054, or about 5.4%. Right, that is it for this problem.